Hello, aspiring Richmond scientists, and welcome to another edition of RPS Home, 5th grade science edition, week 9. I am Mr. Jackson at Southampton Elementary. If you note, I have a different background because I love space, and I hope you got to see that rocket go up the other day. That's the first time in a long time we haven't had to hitch a ride with the Russians. We are now back in the space business. Yay. So here's a beautiful galaxy for you to admire. Anyway, let me shrink my head. Again, Mr. Jackson, Southampton Elementary. We are continuing our study of 4.5 ecosystems and what a niche is, how it changes in an organism's life cycle, and today we're going to introduce influences of human activity on ecosystems. So let's just go ahead and dive right on in. Ecosystem, relationships, interactions between living and non-living organisms. What I asked you to do Monday was look at a video of a frog and a pond someone made in someone's backyard. And you saw the predator-prey relationships. Hopefully you thought about what the job was of that organism, but let's think about it a different way. The niche or the job or the role of the ecosystem. When you think about that frog, what was its job at its point in its life cycle? It looked like an adult, so all it needed to do was eat, take care of itself, and avoid predators. But what about the niche of the bugs? What's their job in that ecosystem? Well, they're doing the same thing, but also they're food. So they are actually part of the ecosystem, and it has to be there because organisms have to eat. And this goes into that weird predator-prey relationship. And sometimes predators can turn into prey, and then it's a prey-predator relationship. We'll get into that a little bit more in just a minute. But like the flowers in that video, what's their role? The lily pads. What was their job in an ecosystem? Usually it's to provide shelter, habitat. Sometimes it's a food source. So what I want you to think about is how a job can change through the course of an organism's life cycle. So I asked you to look at this and I asked you to think about how their job can change through the course of their life. So we just talked about the adult frog. And the adult frog, she's taking care of herself. She's eating. She's avoiding predators. She stays near water because she's an amphibian and they love water. So their job is to eat, take care of themselves, find a mate, and reproduce. So here we have reproduction right here, these eggs. What's their job? They don't really have a job right now. They're just hiding because they're not really doing anything but just growing. But we move along in the life cycle and the egg turns into a tadpole, and then the tadpole turns into legs, and you see it start to take the shape of what it's going to be like when it's older. But here is my interesting question. What is their role? Sadly enough, boys and girls, in the world of animals, they are food for another organism. So a predator is going to eat them. Sad, but true. So to make you feel a little bit better, let's say there's 200 eggs here. They say that if 5% of these eggs survive, then the frogs will be fine in their ecosystem and things will move along. So let's say this is 200 eggs. 10% of 200 is 20. And I wanted 5. So half of 20 is 10. So out of 200 eggs, if 10 of them survive and mature to that size of a frog, the ecosystem will be fine. So what happens to the other 190? You got it. Food for something else. So what I want you to start thinking about is how that niche or that job, that role that it plays in the ecosystem, what is it? because it changes through the course of their life. Food, well, it can be food all the time, but once it gets here, it has the capacity to reproduce and make new versions of itself. So that's pretty much what we do on this planet. We make new versions of ourselves and we take care of ourselves along the way. So start to think about what an organism's niche or job is in the course of their life and how it changes. Another thing I asked you to do was take a look at this baby deer or fawn and this adult buck right here. This is a buck because it has antlers. Now, what is the role of a fawn? Well, it still has spots, so that's camouflage for this creature because it's just going to hide because predators are going to come right along and do what? That's right, gobble it up. So the parents have to take care. But when the parents aren't around, this animal is just going to hide for its defense. So, what is the role? What is the job? What is the niche of this organism? As you can see, I've written across the top. Adaptations change to meet the needs of one's environment. If the organism does not change, it will not survive. So, how is this animal adapted to deal with things? You can look at an organism and pretty much tell its main sense. You look at these big giant ears and you say that animal can hear well. You look at that big giant nose right there and you say that animal has a great sense of smell. But this isn't what I'm talking about. I'm talking about these big things on its head. This 8-point buck right here, these antlers. What is the adaptation? How does it meet the needs of its environment with this? First thing I'm going to think of is protection. This is its main defense. Now it can kick too, but this is their main defense. And also when it meets a doe, the bucks will fight to see who will get to mate with the doe. So usually the bigger set of antlers is going to be the one that wins the fight. They will also take these antlers and rub them on trees to sharpen them up. And primarily, I mean, maybe they'll fight every now and then, fight off other predators, but this is their main adaptation right here. But they do have the sense of smell and they hear well too. So add all these things in. But again, we've been teaching ecosystems for a while now, so you really need to put all these pieces to the puzzle together to think about this stuff. So our main concern is the word niche. The synonym for niche is job. What is the job or the role that organism plays in an ecosystem? So let's try to put some stuff together here. So what have we taught? We've taught a lot of things here. We've talked about adaptations, populations, communities, energy flows, habitats, a niche. So let's go to this predator-prey thing for a second. You see these bigger ones up on the top. They're probably the top predators here. But you think a fox will eat a snake every now and then? You think a hawk will eat any of these? Darn right they will. And what if something changes in the habitat and a new predator is introduced? Then these predators turn into prey. And then what if humans come along and decide to build a Walmart and knock the animal's habitat down? And then you got to have a big giant parking lot for the Walmart too. These animals are going to have to go somewhere else. So ecosystems are relationships. And sadly enough, a lot of the organisms are going to get eaten because energy has to transfer through the food web. Now remember, food webs are really food chains that are overlapping, if you remember me teaching that. Yeah, bigger picture here is the energy pyramid. And this is nature's way of distributing energy. So if you remember me saying nature, it has a good way of balancing things out. It does a very good job because plants and animals have been on this planet for millions of years and they've had a long time to change to meet the needs of their environment. So nature, it distributes energy, producers, consumers, and decomposers. But let me throw a little math at you. If you remember me talking about that pizza, I said if there was a pizza and there were 10 slices, only one slice would be the energy that passes on to the next organism. So think about that frog in that pond. How many bugs, beetles, crickets, how many would it have to eat to get the energy that it needs? Well, that depends on its age, its size, how big the creatures were that it ate. But what I want you to see is this 100 goes to 10, and this 10 goes to 1, and this 1 goes to 1/10. So what you're really doing here is dividing it by 10, or moving the decimal place to the left, well, to the right. So 100 goes to 10, 10 goes to 1, 1 goes to 1/10. Now, this is a lot of math, and we're getting into some middle school stuff, but all I want you to see is how energy is transferred to the next creature. And depending on how big it is, and how big it is, depends on how many it's got to eat. But you have different tiered consumers: primary, secondary, tertiary, I hope I said that right. And then you have producers. So the producers are the only ones that can make their energy. And where are they getting their energy from? They're getting their energy from the sun. So if there was not a sun, we would not have life on this planet. If there were not plants making their own energy, we would not have life on this planet. So life is a delicate balance, and that's what nature does. And the last thing, you see this math on the bottom, energy pyramid. Only 1/10 or 1/10 of the energy passes on. So if you're good at math, you see a fraction and a decimal right there. And ladies and gentlemen, those are exactly the same things. That's 1/10 the fraction, that's 1/10 the decimal. And that's the only amount of energy that passes on to the different tiers or layers of this energy pyramid. So let's teach something new. And this is kind of a bummer because this is about us, Homo sapiens or humans. So here's a graph. Influences of human activity on ecosystems. Excuse me. So let's take a look at this. 25% of human influence is good. 75% of human influence is bad. As you read this, are humans good for this planet or bad for this planet? Yeah, you got it. It's bad. So think about this. What do humans do that are good? What do humans do that are bad? Mr. Pryor talked a lot about the good ones. I, unfortunately, am going to talk about the bad ones. So let's lay a couple things on you. Now, you would think that us humans make the world a great place: sunshine, puppies, ice cream. It doesn't work like that. This is the effects here. So this is nature if you left it alone. This is nature after us, Homo sapiens, get a hold of it. So sadly enough, here is the main thing right here. I'm going to let you look at this for a second. I could find some terrible pictures on the internet, and this is the least offensive one. The least. So what do you see here? Here's a drain. What's spilling into the ocean? Trash, pollution. What's leaking out of that boat? Pollution. What's floating in the water? Trash. And what do the little animals do? They don't know any different. They think it's food. They're going to eat it. So eventually that's going to work its way up the food chain. And who's going to be affected by all this? We are. So we really need to get a handle on this. We are supposedly the smartest things on this planet, but I really, really don't see that sometimes, especially the way the world's been going here lately. But anywho, we need to see ourselves as stewards. And the word steward means we take care of the things that can't be taken care of. We need to realize that we control all this and we could do a lot better job as a species. But there's a lot of things we could do better. Now, let's open up some new vocabulary. And our first word is overpopulation. So go back to the idea of me telling you that I am a reading teacher as well. You see the word within the word, overpopulation, population, populace. You put over in front of this, that means too many. So when there are too many people for the environment to handle it, if you've ever been somewhere like New York City, you see that there are a lot of people living there. Here in Virginia, it's not as bad, but like you get into an apartment complex or in the city, you see that people are really crowded together. Well, this is a problem. This is a big problem because there are a lot of humans on this planet and we have a lot of needs. And sadly enough, we aren't looking out for other people. Sadly enough, we're looking out for ourselves. And hopefully that changes. Overpopulation, too many people. Pollution, harmful or poisonous substances introduced into an environment. I just showed you a picture of that. I think you can come up with a lot of different examples there. Burning fossil fuels. So here I go back into the rock cycle. If you remember fossil fuels and you remember third grade, fossil fuels are plants and animals that have been changed into crude oil, that black bubbly stuff that they get up out of the ground and turn into gas and kerosene, and coal, something else that they burn to heat up houses. Actually, that's a main form of electricity too, is burning coal to heat up water, to make steam, to turn a turbine, to make electricity with a microfaraday generator. But burning fossil fuels, this releases stored carbon into the atmosphere. So anything that is living is an organism, and all organisms contain carbon. And when you burn this stored up fossil fuel, which is really carbon, you're releasing it into the atmosphere. And that's a simple way of thinking about this, is it makes the atmosphere thicker and it makes the planet warmer. Now you're saying, oh yay, I like it warm. I don't like cold, Mr. Jackson. I like it warm. Well, icebergs don't like warm. And we're raising the temperature of this planet by burning too many fossil fuels. This is a bad influence of humans. Deforestation. The word within the word forest, you put D in the front of it, that means decrease. So decrease forests. Removing forests / trees to use land for something else. In Brazil, they have these beautiful rainforests, but amazingly, they're cutting down about the size of 3 football fields a day to take those rainforests and raise cattle. Why? Because they can't make any money off the rainforest, but they can make money off cattle because that's where our cheeseburgers come from. So they're cutting down forests to make money. This is not good because rainforests are so complex, they're so big, they create their own weather systems. And we are changing a lot of things. Now, this just isn't happening in Brazil. This is happening all over because what are they going to do? They're going to cut a forest down to make another Walmart. Moving on. Mining. Removing valuable minerals / materials from the earth. Why do we do this? Because we want minerals, we want ores, we want gold out of the ground. What do? They dig a big giant hole. They leave the hole there to get what we want out of the ground, and then they just pretty much leave it there. And that is another bad influence of humans on this planet. Climate change. And yeah, let's save the I know this is very negative, boys and girls, but I'll save the worst one for last. Climate change. Change in global climate. And climate just means weather over time. So if we lived near the equator, it would be warmer because the rays of the sun do a better job of heating the ground there. So it's hotter at the equator. So think about the weather there. It's going to rain more because there's more heat. On the poles, the North Pole and the South Pole, the light from the sun kind of bounces off. It doesn't heat the ground. It stays cold there. So what do we have there? We have polar tundra regions. So climate change, we're changing weather over time because we are burning too many fossil fuels. These fossil fuels get in the atmosphere, they make the atmosphere thicker, the temperature goes up. And sadly enough, what we do to the atmosphere affects the ocean. And actually, we are changing the pH or the acidity level in the oceans too. Guys, we got to find a better way. There has to be a better way. So, sadly enough, we think we're the smartest things on this planet. We need to take a strong look at ourselves and say, ugh. So, what I'd like to do now is explain what you will be doing. So, day 2, explain and extent. Gets a little better now, ladies and gentlemen. Sorry for all that, but I know I bummed you out on some of that. But what I found for you is a great movie. This is a movie on wolves being reintroduced to Yellowstone. Yellowstone is a beautiful park out in the Midwest towards the Rocky Mountains. So it's a beautiful, beautiful place. But guess what? Humans decided to take the wolves out of this place because these are predatory animals, and well, those predatory animals were eating too many livestock. So in 1926, let me look at my notes. In 1926, we had what was called the Government Predatory Control Program. So they thought if they removed the wolves, people's cows wouldn't be eaten as much then, or sheep, or lambs, or llamas, or whatever you think a wolf would say yummy delicious to. So they took them out of Yellowstone, and no less than 15, 20 years later, they started seeing a lot of different changes. So this says how wolves change rivers. Yes, ladies and gentlemen, changed rivers. Check it out. This is a great video. It is very, very interesting. So what you're going to do is watch that and then hop on over to your student journal. Remember, you make it, you click on it. Let me just hop on over to mine. What I want you to do is watch that video and list before and after effects of wolves in the park below. So, one of the biggest things you do in 5th grade science is realize the word variables. And there's 2 types of variables. There's a cause variable and there's an effect variable. There's an independent variable and a dependent variable. Something is manipulated, something responds. So this is the same thing that you see in reading too. There's a cause and then there is an effect. So the cause in this video is humans purposefully removed wolves from the park. The effect, I want you to watch that video and write down the different effects that you see. The effects of having wolves in the park and the effects of not having wolves in the park. And this, once you master this skill and you realize the cause and effect relationships, you really, really, really start to see science in a better way. So please check out the video and list the effects from humans purposefully removing those wolves from the park. After you watch it, can you give examples of how wolves created a natural balance? So remember, nature does a good job of balancing things, and us humans, we think we're smart. We think we know it all. We do not. What happened here? How did those wolves create a natural balance? Very interesting. So after that, write down the definitions that we've learned. So overpopulation, pollution, burning fossil fuels, deforestation, mining, and climate change. After you write down your definitions, please simply go to a matching exercise and match those words. Overpopulation, pollution, burning fossil fuels, deforestation, mining, and climate change. Please just figure out which one goes to which picture. Look at that. Mm, mm, uh. And these are all effects from humans. If there were no humans on this planet, you would not see these pictures right now. And this is a culminator here. This is the effects of that. So think about that and try to match them. Finally, day 3, I'd like for you to do some gizmos. So we have pond ecosystems, we have prairie ecosystems, and we have forest ecosystems. I'm only asking that you do 2. You can do all 3 if you like. Log into Clever, click on the link. I love some gizmos. You launch the gizmo, you use this button right here to make the gizmo bigger. Uh-oh. Oh, look at that. Didn't like me. I had to log into Clever. So you can change the amounts of organisms. You can change grass. You can change all different sorts of things. You run it and you collect data. Cool thing here is you can flip right over to this and you can see a graph. So the scientific method, we run experiments to collect data to see what the data tells us. So you can run all these and it'll show you a graph. A graph shows you math in a pleasing way. It's much better than looking at a table of numbers. This will show you, oh, the numbers are going up, the numbers are going down, they're increasing, they're decreasing, we see growth, we see decay. You can make a line graph, do all different sorts of things. This is really nice, ladies and gentlemen. And please realize, math is part of science because we collect data. And how do we collect data? We count things or we measure them. After you're done with this, you can go down to some assessment questions down on the bottom and see if you have mastered this. But before you start clicking on things, realize that you can manipulate the stuff on the gizmo to get the answer. Great stuff. Please use your gizmos. So you have a pond gizmo, a prairie gizmo, and a forest gizmo. After that, go to solpass.org and see if you can pass this thing right here. And these are SOL release questions here. These are not easy. If you got this, you've got this. After you do it, check your answers. There's a key somewhere, and then see if your parents can answer them and show them how smart you are. So please don't forget about SOL Pass. It is fantastic. There's study guides, there's tools. Remember, the password is Richmond. You just click on the name of your school and the drop down box. You can use this for a lot of different subjects. This is a very nice thing. Finally, you're going to go to Flipgrid and create an ecosystem of your choice. So here's 8 different ecosystems. So if you remember last week, I asked you to research an organism. Well, I want you to find the habitat for that organism right now. Does your organism live where it's water, aquatic, or land, terrestrial? Please go to Flipgrid and post your picture. And might I give a shout out to Caleb A. and his saber-toothed tiger. Thank you for posting on Flipgrid and showing me your wonderful work, Caleb. Thank you. So, where would your saber-toothed tiger live? I picked gray wolves. They live usually in a tundra, forest, rolling hills. I picked this because it's snow covered and I didn't have to color anything. So, that ends what we were doing today. What I would say to you is I hope that you've learned some stuff. I hope you've enjoyed spending time with me. This will be the last time you see Mr. Jackson. So 3 things for you. Please stay safe. It's rough out there, boys and girls. Try to learn something new every day because knowledge is something no one can ever take away from you. And the way the world's going nowadays, ladies and gentlemen, please think of the golden rule. Treat people the way you want to be treated. The world would be a much, much, much better place if we knew how to take care of each other. Think about what I'm talking about with ecosystems, too. Thank you for spending time with me. I hope you enjoyed this. I hope you learned something. Stay safe. Bye bye.